Charles' Law. The thing that basically runs the world like a king's souped up attorney power, except that power is chemicals and the king is the earth. Yeah. But I digress. Little background knowledge on Charles. His full name is
John C.
His full name is Jack. This guy. There you go. Born in France, he became immensely good in mathematics, excelling in science, including physics, and eventually gained the status of a French inventor for, you guessed it, French fries. Just kidding. But he invented hydrogen balloons, which led to man-driven balloons. Thanks to him, it has inspired hot air balloons and blimps. Now for the law itself. Charles' law states that as temperature increases, the volume also increases proportionally, assuming that pressure and the number of particles remain constant. Alright, now for a quick demonstration of Charles' law. Now, what I have here is a bottle of water, and I have squeezed some of the air out so you can see the bottle itself expand. Now, this is at room temperature. As I put it in a pot of boiling water, you should see the bottle expand because the boiling water is at a high temperature, thus the volume also increases proportionally. And of course, if I put it in cold water, it should go back to its original state where it is at a much lower temperature, and thus the volume also lowers, as you can see. Now, how do you actually solve a problem like this? Let's use the bottle example again. A glass bottle with a volume 3 milliliters sits at room temperature at 21 degrees Celsius. It falls into a fireplace, and the temperature increases to 1500 degrees Celsius. Using the equation V1 over T1 equals V2 over T2, we can plug this in and find out the current volume. Before we can even try this, we have to convert Celsius into Kelvin. How this works is 273 plus Celsius. So T1 is 21 plus 273 equals 294 Kelvin. And T2 is 1500 plus 273 equals 1773 Kelvin. Now we can plug this in. V1 is 3 for milliliters. T1 is 294 and T2 is 1773. And V2 is our variable. Cross multiply and boom! Our new volume is 18.09 milliliters. Now, how is this applied to everyday life? Imagine it's winter and you want to play football outside. You inflate that thing inside your house, and when you go outside to play, you notice it's starting to lose its air. In fact, it's not. Because of the colder temperature outside, the temperature inside is now decreasing. The volume is also decreasing, thus the feel of a less inflated ball. This is actually how the law was almost found, except the ball were 5 balloons. At around 1787, Charles did an experiment where he filled 5 balloons to the same volume with different gases. He then raised the temperature of the balloons to 80 degrees Celsius and noticed they all increased in volume by the same amount. Of course, this discovery was known as Charles' Law.